Capacitance. A capacitor is an electrical component composed of two conductors separated by a certain distance, each with equal but opposite charges, plus Q and negative Q. If you look at this diagram down here, this section of two metal plates is what we call the capacitor. Now the capacitor is separated by a certain distance, we call this distance d, and each plate has a different charge, equal in magnitude but opposite in direction. Another symbol that we use in schematic diagrams for capacitors is two parallel lines, different from a battery in which the lines are also parallel but of different sizes. So we call this a capacitor. Now, capacitors, what are they used for? They're used as temporary batteries. Okay? Almost all electrical devices have capacitors in them. They maintain power supplies while, for instance, batteries are being changed. This could help to serve memory loss. For example, in your calculator likely has a capacitor in it, so that when you remove the batteries, there is still some power supply being supplied to the calculator so that you don't lose the information that you had in the calculator before the batteries are being removed. They're kind of like a backup system. Next word, capacitance. Capacitance is the actual measure of the capacity for holding charge. The greater the capacitance, the greater the amount of charge that can be stored on the plates, on the parallel plates, at a given potential difference. The units for capacitance are coulombs per volt, or what we call farads, F. Lastly, epsilon 0 is the permittivity and is the measure of the resistance of an electric field in a medium. The permittivity of vacuum is 8.85 times 10 to the negative 12th farads per meter. Now, basically, permittivity is telling you that different medium or different media, let's say air, liquid, the permittivity, the resistance of an electric field changes. For simplicity purposes, we will use this value of permittivity in all of our problems. Now, here are the two equations that we need to know. The first equation is C equals Q divided by V, or capacitance equals charge divided by potential difference. And the second is epsilon 0, permittivity, times the area of the plates divided by the distance. Let's go over the couple units we need. So again, capacitance is given by C, and the unit is farads. Q, we already know. Voltage, we've been over. Area is the area on the plates, and that's meters squared. And lastly, D is the distance between the plates, and that's in meters. Epsilon 0 will always be provided to you in the problems.